Hey there, this is Akshanandan and welcome back to a new video. And in this video, we are going to make a brand new project that is about emotion detection model using Keras and convolutional neural networks. And we are also going to use OpenCV to test our model. So first of all, I'm going to show you what are we going to end with. So let me run my code. So this is the file which is using the CNN model which I have built using the Kaggle dataset, and we are going to build the dataset on Kaggle kernel only so that you don't need to download the whole dataset because it's of huge size, right? So we are going to build the model on Kaggle kernel and we are going to download that model, and then we are going to write this whole code which is the OpenCV code, and it is going to use your built model and it is going to show you the results. So basically I'm focusing on these seven emotions, that is angry, disgusting, fear, happy, neutral, sad and surprise. The accuracy of my model is around 72%. That's a okay, and you can say that's a good accuracy because you are having so much images and you are having seven classes, right? So that's you can say that it's a good accuracy, right? So let's run the code and let me show you the output of our project. So hey there everybody. So first of all, I've downloaded some sample images on my phone so that I don't need to make emotions, each and every emotions, right? So first of all, I'm going to show you this face of a girl that is detecting it to be happy, and you can see only that it's a happy face. So let me use the next image, and you can see that's a angry face, and it is detecting very perfectly that it's a angry face, and it is showing my face as neutral only because I'm making a neutral face. I'm very bad at showing the fake emotions. So let me show you the next image. That's a kind of surprise, or you can say fear, but it is telling it that it's a surprised image. Okay, that's not a problem. And next image I have, again it is telling this image as happy, but I think it's a surprise. So yeah, as you can see, it is getting shifted towards surprise and happy. I think it's a bit confused whether it is happy or it is surprise, right? Because it is continuously changing its answer, surprise or happy. Maybe. Next image is again a happy image. You can see the next image is a kind of anger. Yeah, it's angry image of a lady. Next image is kind of sad. It is detecting, but I think it's a kind of confused image, but it is telling that it's a sad image. Okay, no problem. And now I'm going to test with multiple images, right? Multiple images in one photo. So each and every face is getting detected using cascade classifier, and it is telling that they are having these emotions, right? Amazing. Now coming to the next image is again many faces, and it is telling me that these are the respective output emotions, right? So this is the output that we are going to build in this project. And without wasting more time, I think we should first go to Kaggle and let's peep into the data set. And then we are first of all going to make the model, that is CNN model, and we are going to download it and we are going to use it for our OpenCV, right? So let's start coding. Now, as you can see, I'm on my Kaggle.com, and I'm on the dataset that I'm going to use for this video or this project, and this is by Jonathan O'Hacks. So a lot of thanks to the author for making such a beautiful dataset. And it is containing two directories. I can see that training part and the validation directory, and they are again containing seven directories which are for seven different emotions. So if I go into the training part, and I can see that there are seven different kinds of directories which are containing files in thousands, right? So this angry folder is containing the files of the they are containing the images of the angry, which basically depict the anger face, so that it can be fed to the model and it gets trained. So like this, you can just go through each and every folder, and you can see. So as you already know, for each and every model, we need a training part and we need some validation data. So here also we are having one training directory and the other one is the validation directory, which is again containing the seven different directories, right? So as you know that it is a detailed explanation video, and I'm going to explain as much as I can do. And if some things get missed, you can tell me in the comment section. I'm going to make a separate video for that particular topic, right? So this is the training part and this is the validation part. So okay, Now let's go to Kaggle kernel. I'm going to use Kaggle kernel so that I don't need to download this dataset that is of 121 MB, right? So I'm going to use the Kaggle kernel and I'm going to download the model that we are going to build, right? So let's first go to Kaggle kernel, and this is the dataset that I'm using that I've already shown you. Now, first of all, I'm importing the important libraries. So first of all, I'm importing the Matplotlib, NumPy, Pandas, and Seaborn. These libraries are basically for data analysis and data visualization, right? I hope it is clear because I have covered it in many of my Kaggle videos and other videos also. Then I'm importing OS so that I can import or I can call the files, the image files that are for training and validation, so that I can show you which are my files using Matplotlib. I'm going to show you in the further part, don't worry. Then I'm importing the deep learning libraries that are going to be used for building the model, the CNN model. So for that, I'm going to import the load image. So to load the images and image to array so that I can convert my images into array so that I can fit into my model very easily, because model will not take the image, right? It will take the array form of the image, right? Then I'm going to import the image data generator, and I'm going to explain what is the use of image data generator in when it is going to come into our process. Then I'm importing the important layers which are required for making the CNN model, right? So as you know that every artificial neural network is a collection of some layers, the hidden layers or the input layer or the output layers. Like this, we are going to import these layers which are used to build the model, right? So first of all, it is the dense layer, then input layer, dropout layer, global average pooling 2D, then flatten, then convolutional 2D, batch normalization, activation, and max pooling 2D. Then we are going to import sequential model from keras.models. Then we are going to import some of the optimizers, and let's see which one we are going to use. I hope it is clear up till until now, right? Now let me run this thing, and we have imported all the important libraries. Now we are going to display some of the images so that you get an idea what are the images we are going to use for building the model. So I'm standardizing the size of each and every picture because it is not necessary that each picture is of one standard size. So I have to standardize the size of each and every picture, which I am choosing it to be 48 into 48, right? So first of all, I'm defining the folder path. So I'm defining this path. So as you can see, which is containing my images, that is training and validation. So I'm copying the path from here and I'm pasting it over here, right? Then after this, I'm going to plot some of the images from my disgusting folder, right? Which is containing the images of disgusting face, right? So let's do that. So for that, I'm defining the expression it to be disgusting, and if I change it to be anger or sad then happy, you will see those images respectively, right? Then I'm defining the figure size of my matplotlib graph, that is 12 by 12, and for I in range 1 comma 10 to 1. So as you can see that if I go into my training part and I'm going to disgusting folder, I can see that all these images are numbered from one number to different number, which are having the same interval, right? So if I'm finding 31, 32, then I will find 33, maybe not in series, but they are there, right? So all the images are in sequence, right? So I'm defining the images from 1 to 10 because I want to plot the images from index 1 to index 9. That's why 1 to 10, and with the interval of 1. Then I'm going to plot the subplot using matplotlib. If you don't know, you can follow my matplotlib video, and I'm defining the subplot size to be 3 by 3, right? So 3 by 3. So as you can see in my output, 3 by 3 matrix is formed, subplot is formed using matplotlib, and I'm defining the position. So in subplot, you need to define the position of that particular graph, of that particular image, if I'm more precisely over here, right? So it is I, right? Then I'm going to load the image. So I'm defining this load image function, and I'm defining the folder path plus train slash expression. So as you can see, I have to go inside these images which I've defined the path over here. Then I have to go inside the training part, then I have to go inside the expression part which I've defined over here, right? So let me increase the font so that it is more clear to you, right? So going inside the folder path, then I'm going inside the training path, then I'm going inside the expression, that is disgusting, and after this I'm going to show the images which are present over here with these indexes, right? So os.list directory, then folder path plus training, then expression at I. So all the images at index 1, then index 2, then index 3, then index 4 till index 9. Then I'm going to those things, those folders, those images I'm going to show you, right? Target size is picture size comma picture size, because I want to standardize the size to 48 by 48. So I've defined the picture size which I've defined over here, and it is defined over here, that is 48, right? So 48 by 48 is the standardized size which I've chosen, right? Then I'm going to show the image. So using plt.im show image, this is the function to show the image using matplotlib, right? And after this, I'm defining plt.show. If you will run this, you can see that these are the images. So I want that it should be in a dark theme. So let me set these plt.style plt.style.use dark background. Let me run it again. And you can see that I can see the numbers also now because I'm a dark theme lover. That's why I'm doing it, right? So 9 by 9 images I can see. So first 9 images it is showing me, right? So if I change the directory to angry, then it will show me the first 9 indexes images of angry folder. Let me run it. So these are the angry images. Like this I can change it to happy, and you can check each and every folder of your choice, right? So you can see that all these images are happy. So these are the training images, right? Make the training and the validation data. It's like a train test bit, but as you can see that the data is already split it into training and the validation, right? So here we have to do something different. That what I'm doing, first of all, you need to define the batch size. Now, what is the batch size? So as you know that this video is completely detailed video, but I think I may miss some of the points which you can tell me in the comment section. I will make a separate video for that, right? So batch size is basically a size, or it's a number, and it depicts that how much training example, how many training example your model should take in one iteration, right? So batch size I'm defining it to be 128. So it means that it should in one iteration it should take 128 training examples, 128 training files. You can say more precisely, right? So then I'm defining two variables that are datagen train and datagen validation, right? And I'm defining it to be as image data generator, right? So image data generator and image data generator, right? Then after this, I'm defining two variables that are train set and the test set, or you can say the validation set. It's totally up to you. Then these variables are going to contain the data which is coming from the directory. So how we can define it? So data gen train, that is this variable, which is an image data generator. You can say an object of image data generator dot flow from directory. That means the data which is present in this directory, that is folder path plus train. The folder path is defined over here, that is still images, and after this I am adding the train string, that is it should go inside the training folder, and it should take all the images from it, and it should give it to this data gen train, and after giving it to the image data generator, it should be stored in the training set. Clear? I'm defining the target size of the image. So as I've already told you earlier that we have to standardize the size of each and every image file. So for that, I'm defining the target size of the image, each and every file that it is going to get iterated. Picture size, comma picture size, that is 48 by 48. Color mode is grayscale because I want to read the images in grayscale. Batch size is batch size. Then I'm defining the class mode as categorical because there are seven different categories of outputs: angry, disgusting, sad, neutral, like this. So this class mode will be categorical. Then shuffle is true to shuffle the image. The name only tells it. I'm going to do the same thing for my validation data, right? So training set is ready, validation set is ready, or you can say the test set is ready, right? Then it is telling me that it has found 28,821 images in my belonging to 7 classes, that is for training. Then 7,066 images in my validation folder, 7 classes, right? I hope it is clear to you. Now we are moving to the most important part, that is defining the model. So here we are going to build the artificial neural network that is going to detect different emotions. Cool, right? So for that, I'm defining the model, and I'm going to import the optimizers, which I've already imported. So I think we don't need to write this statement, and I think I'm not using it anywhere in the process, right? So I'm defining the number of classes as 7 because there are 7 different possible outcomes. Then model as sequential, we are going to use a sequential model. Then this is the first convolutional neural network layer. So you know that in artificial neural network we have different layers. Input layer is there, dropout layer is there, flatten layer is, activation layer is there. Then hidden layers are there, different, right? So we are going to define these layers, right? So these all layers combined will make your artificial neural network, or you can say the deep neural network, right? So first of all, I'm defining the convolutional neural network, and 64 filters I'm going to define, which are of 3 by 3. 3 by 3 is a kernel size. So if you don't know about this kernel size and what are the number of filters, Just tell me in the comment section. I'm going to make a separate video for all this because I can't cover each and everything in this. So, right. So I'm defining and I'm trying to explain each and everything which can be possible. Right. So I'm defining 64 filters and 3 by 3 size. So 3 by 3 size is the kernel size. Padding. I'm keeping it to be same from every side of your convolutional neural network layer. So you don't know that. I think you know that in convolutional neural network we are going to place the kernel on each and every part, and we are going to shift the kernel at every iteration with your defined stride, right? So input shape is 48 comma 48 comma 1, right? So 1 because our image is now grayscale image, and 48 by 48 is your shape of your image, right? Then I'm defining the patch normalization layer. After this, we have the activation layer, and activation layer is present at the end of the neuron, and it basically decides what data should be fired to the next layer, right? And we are defining the rectified linear because it does not start all the neurons, it does not triggers all the neurons at the same time, right? So it is considered ReLU is considered as the best activation function for these kind of data sets, right? Then we have the max pooling 2D, and what does this max pooling 2D does? First of all, you need to define the pool size, which we are defining 2 by 2, and it basically extracts the important information from that area where we are putting that pool, which whose size is 2 by 2, right? So it extracts the important feature from that particular area of that image, right? So for that, we need to define max pooling 2D, and we are defining dropout to prevent our model to get overfitted, right? So these are the important just key points I have told you for each and every layer. Then after this, again, we are going to define the second CNN layer, and we are defining convo 2D. Then important step that is you need to define the input shape only in the first layer, right? You don't need to define the input shape in every in each and every layer. So here we are not defining the input shape. Then rest of the things are same, and the kernel, the number of filters we are defining 128, right? Then after this, we are defining the number of filters at 512. Then again, I have defined this 4 CNN layer, then this flatten layer. The function of this flatten layer is to collapse the input size, or you can say the input, to one dimensional array, which can be fed into a model very easily. So this is the function of the flatten, right? Then we are defining the fully connected first layer. That is, we are connecting all these layers using the dense, right? So we are connecting all these layers, okay? Then after this, what I'm doing, I'm defining the Adam optimizer. So I'm defining this Adam optimizer with my learning rate is 0.0001, and I'm defining this Adam optimizer with into my variable that is opt. Then I'm going to define my model.compile, and I'm defining the optimizer into it. Then loss, which is categorical cross entropy, because there are different categories. So I'm going to use categorical cross entropy loss. Then the metrics I have kept it to be accuracy. Then I'm printing the model.summary. So this is the summary of my model, and it defines all the important layers which I have used, and their sizes like that data is there. So now let's fit the model with my training and the validation data, right? So for that, I'm importing these three important functions from my Keras.callbacks class, right? So first of all, it's your model checkpoint, then early stopping, then reduce LR on, reduce learning rate on plateau, you can say, right? So checkpoint, consider it as a police check post, right? So police checkpoint is just checks you off when there is some criminal cases going on, like it's there are some certain check post of police, right? So checkpoint is the same thing. So it is going to check your model at each and every point, and it is going to save your model in this path. So what I've done, I'm saving my model in my this output kaggle. So this is the default output folder which you get from kaggle. So when you will copy this path, and you're going to get this two thing, that is dot then slash, and this is the name of your model which you want to save, right? So I'm defining it to be model.h5 file. Then monitor is I'm keeping it to be validation accuracy, so it is going to monitor my validation accuracy. Then verbose is 1, then save best model is true, then mode is max. And if you don't know about any of these factors, you can tell me in the comment section, and you can just check it on the net also. You will just type verbose, meaning of verbose in machine learning, and you are going to get the answer, right? So certain things I'm just leaving for you, so that you should also do some research. So these small parameters you can just search on the internet, right? Then I'm also defining the early stopping. So if I'm getting the best model and the validation, if and my accuracy is not increasing, then it is going to early stop, so that it should not overfit my model, right? If my model accuracy is not increasing, then just continuing with the number of epochs is just time wasting, right? That's why we need to define the early stopping. So, and I'm keeping the monitor at validation accuracy. Then these are again certain parameters. So restore best weights, that means it is going to restore the best weights which I'm getting, the best model, right? Then I have to define the reduced learning rate. So if my model is not able to cope up with the particular learning rate which I have defined earlier, then it is going to reduce the learning rate. Factor is zero point 0.2, patience is 3, verbose is 1, minimum delta is 0.0001, right? Then I'm defining callbacks list, which is going to contain, it is basically a list which is going to contain all my three parameters, that is early stopping, reduced learning rate, and my what is checkpoint, right? Right. Okay. Then after this, I'm defining the epochs as 48. Then I'm going to fit my model with my training set and my test set, uh, which I'm ready. Yeah, this training set and the test set. So which I have taken from my folder, data set folder, right? I've defined the class mode, I've defined the batch size, I've defined the color mode, right? So I'm ready with the training set and my validation set. So I'm going to define the generator as train set. Steps per epoch is the, so you already know the formula of steps per epoch, which is the length of your training set, that is train set dot n, that is for training set length, divide by the batch size, so training set dot batch size. Then you need to define the epochs, which is 48. Then you need to define the validation data, which is test set. Then validation steps formula you also know, that is the length of test set divided by the batch size of the test set. Then you need to define the callbacks, which are these three things: early stopping, checkpoint, and reduced learning rate. Then when I did all this stuff, I saw that my accuracy was 67% and my validation accuracy is around 53%. And it has almost changed, because when I first did it, when I was writing the statement, when I was writing this kernel, then I was getting the accuracy was around 70% and my validation accuracy was around 69%. So it has decreased. So it can change, right? So when you will do it, it may come above also and it may come below also. So you should try it, and you can change all these factors. And when you get the best accuracy, that's good, right? So the model which I'm using for that OpenCV and which I've provided on the GitHub, and the link is given in the description, that is having validation accuracy is around 16%, and my accuracy of this model is around 72 or 71%. It was, right? Okay, that's not a big deal. Then I'm just plotting the accuracy and the losses. So when you will plot all this stuff, that I'm using just a simple matplotlib thing, and when you will plot this accuracy and your loss, then you will see that these are my loss, which are getting decreased from time to time, and these are my accuracies which are getting increasing, which is increasing from time, right? Okay, that's a good thing. And when I will I can, let me see if I am getting the model over here. I think I just refreshed that Kaggle kernel. That's why my model.h5 file is gone. So I'm not going to train my model again because it is going to take a lot of time. But yeah, when you will run it, then you will get a file over here, that is model.h5 file which we have built. Just download it. You will get a menu and just click on that and you will get the download button. So when you will download it, you will get your model.h5 file like this. So model.h5 file, I've just downloaded it, so that's why I'm getting my model.h5 file. Then just copy it and you can paste it in your folder, that is your project folder. So in my Python project folder, I have defined this emotion detection CNN folder, and I've defined this main.py, that is for OpenCV model, which I'm going to just make in front of you. Then I'm pasting that model.h5 file, which is going to be useful when I'm making that OpenCV thing, right? Then this har cascade frontal face default. So I'm requiring this har cascade for detecting my faces, right? So for this, you need to get this frontal face. And this is the Kaggle kernel file, which I've just like this file I'm talking about, which I've just run, right? So I'm giving all these four things, that is pre-built model, and then this main py, R Cascade, and your IPython notebook. These four things I'm giving in my GitHub repository. You can check that out. Right. So let's go to main.py, and now let's start coding the OpenCV. Right. OpenCV model. So for OpenCV, I'm going to import this load model, because I need to load my model, that model.h5 file. I need to import it, right? So for that, I'm importing this load model function from my keras.models class. Then from pre-processing, I'm importing image to array, so that I can, then after this I'm importing image from my Keras pre-processing. Then I'm importing CV2 and NumPy. So first of all, I'm defining my cascade classifier, that is face cascade classifier, and this is the location. So you don't forget to write the raw path. That's why I'm defining this R. And this path, the whole path is generally denoting this whole path, right? So this path. So I'm defining the Har cascade frontal face. So after this, just write it over here. Just copy paste all this, all that path, and just write one more backslash and write that Har cascade frontal face default.xml, right? Then after this, I am defining my model.h5. So using load model, I'm going to define my model, that is model.h5. The whole location is pasted over here. Then the emotion labels. So I'm defining a list which is containing all my possible emotions, output, possible outcomes, that is angry, disgusting, fear, and so on. Then I'm defining the cap, that is for video capture. I'm defining 0 for my default web camera of my laptop. Then using the while loop, so I've already told you how you can just play with your webcam, right? In my OpenCV tutorial playlist, you can check that out. And using the while loop, you can just define two parameters, that is the boolean, that is whether my cap is getting recorded or not. Then this frame is useful because this is the image read by your OpenCV. So then I'm defining the labels. Then I'm converting my frame into grayscale, right? So this faces thing is going to contain all the faces present in my gray image, right? Now this face is using the for loop, it is going to return four parameters, that is x, that y, then w and h for drawing the rectangle. So for each and every faces, so as you have seen in the starting part that it was able to detect multiple faces also, right? So for that we need to use the for loop. And for each face, it is going to give me four parameters, that is x, y, w, and h, and it is going to draw the rectangle around that face, right? So that yellow rectangle was because of this. So we draw a rectangle, then frame on which we are going to draw the rectangle, then the x comma y, then x plus w, y plus h, the color of the rectangle, then the width of that line, rectangular line, right? Then region of interest, I'm interested only this face, right? I'm not interested in any other thing. So that's why I'm defining the region of interest, and grayscale only. So for that gray, I'm defining it to be y to y plus h, x to x plus w, because my face is present in these constraints only, y to y plus h, x plus w, right? Then I'm just resizing my image to 48 by 48 by, because why I'm doing it, because before I speak, just comment down why I'm doing 48 by 48, because my model needs a 48 by 48 image, because my model is trained on 48 by 48 images. That's why I'm converting this region of interest into 48 by 48. Now to standardize my region of interest, I'm dividing it by 255. Then I'm converting this region of interest into gray. That is, sorry, not gray, that array. So my model is trained on getting the arrays. So I'm converting my image into array. So image to array, region of interest. Then using the classifier, that is my model, I'm just predicting the outcome, right? So it is going to predict the particular emotion in my region of interest, right? Then I'm using this prediction.argmax, which is telling, so when it is going to predict the emotions, it is going to give me certain numerical values for each and every emotion, right? Let's say if the image was of angry, then the argument, that is the number given by the classifier, will be maximum for my angry part, right? So I'm going to find which prediction is having the highest numerical value. So I'm going to take that, and that index is going to the emotion present at that index, that is this array. I have defined this array. Now that index will be my output, my answer, right? So I'm doing that thing only. So emotion label present at this index will be my label. So label position will be x comma y minus 10. Why I'm doing y minus 10? Because when I'm not doing this y minus 10, then that output answer was just getting stick to that rectangle. That's why I'm just shifting it a little above. So for that I need to do this minus 10, right? So I'm just printing that text, that is my label, using the cv2 output text, using this font, using this label position, and using this label, the color and the width and your text size, right? Then if my model is not able to find any faces, then it is going to tell that it is not containing any faces or no faces. Then this is the location where I want to put the text. This is the font, this is the text size, this is the color, this is the thickness, right? Then I'm going to show my frame. Then if I click q from my keyboard, it is going to destroy everything. Let's run it and let's finish this tutorial, right? I'm running my code. Okay, I forgot that this is not Python. It is running, and I'm getting an error. Okay. Actually, my webcam is already on because I'm using the OBS Studio. I'm just going to switch off my this thing so that this camera should go for my OpenCV, not for OBS Studio, right? It's running, it is running. Yes, so as you can see, this is my face and it is telling that a neutral face is there. So again, if you want to check the output, I can just show you. Okay, first of all, I need to tell you that I was telling about this area, right? So as you can see that there is a gap between this neutral and this yellow rectangle, right? So if I just remove this y minus 10 that I was telling that I've kept y minus 10, yeah, if I remove this 10 thing, then it is going to get stick to my yellow rectangle. That I was just willing to avoid. Where is it? Where is my file? Okay, I think it is over. Yeah. It has not updated. I want to just quit it and then run it again. Then yes, this one. So as you can see, the neutral is getting touched with this yellow rectangle. That I don't want, right? So I think this much is enough for this video, and like this you can detect any kind of emotions and not just emotions, right? I've told you how you can build a model which is categorical in nature using that data set, and you can just detect anything now using the categorical values of your data set, right? So before I end this session, I want to tell that there is a Telegram channel and you can just join it. The link is given in the description. So if you have any doubts regarding any video and you want to give me some suggestions on which topic I should make different videos, you can just tell me in the Telegram channel, right? So yes, till the next content, keep coding, keep innovating, and thanks a lot.